Welcome back, class. Today we shall see the mathematical implication of Ohm's law. But before this, we have to know the law first of all. I have just rewritten the law again. Let us see. Here the law says that potential difference, which is V, is directly proportional to the current flowing through the conductor. Now here one condition is there, that is T is fixed, T is constant. Remember, it is the temperature which determines this law. Okay, Ohm's law is nothing but the relationship between potential difference and current in a conductor at a constant temperature. Now, this V stands for your potential difference and I stands for current and T is for temperature. Now, the law says the potential difference of across the ends of a conductor. Ends of a conductor means maybe a wire, two end of the wire or two end of any conductor. Now, this is directly proportional to what? To current. This is directly proportional to the current. Now, let us see what comes up. If we remove the sign of proportionality, we get a constant called R. Now, where R is a constant called resistant of the conductor. This R is the resistance of the conductor. Now I shall come to resistance of the conductor later, but here we have to see what it comes up. That means your potential difference is equal to the multiplication of resistance of the conductor and the current flowing through it. If I try to derive R from here, I will get V by I, and if I try to get I from here, I will get V by R. Now these are the formula you can use formula number 1, formula number 2, formula number 3 for doing mathematical sums. Now what I want to say, yesterday in my previous class I have said that if potential difference increases, current also gets increased because they are proportional to each other. Now, provided the temperature should be constant, by the way, of course, now we have to see here resistance. If resistance of a conductor remains, because in a conductor, in the resistance is a constant for a particular conductor. Resistance of a conductor varies from conductor to conductor depending upon the metals of the conductor. Now, the material in the conductor determines the resistance. So, different conductor is made up of different materials. So, for different conductor, resistance value is different. But for a particular conductor, it is always a constant. Now, we shall see here whether these formulae that I have derived are actually in practice or not. Now, let us try to see the other part. The law and other things are here. I have derived this mathematical implication up to here. Now, I wanted to show you whether current increases or not when potential difference gets increased, or whether current decreases or not when potential difference gets decreased. Let us try to see it in a simple way. Just a minute. Let me rub the law because of space problem. Now we have the formula V equal to I R. We have another formula here, R equal to V by I, as well as we have I equal to V by R. Now let me see, suppose V value is, suppose say 10 volt. In a particular conductor, let's say V's value is 10 volt, and here resistance, let's say, is 2 ohm fixed for that conductor, and at the time the current flowing through that conductor, let's say, was suppose let me say 5 ampere. Now let me say the V1, I have increased the value to 20 volt. What will be the amount of current now in this case? But R will remain as it is, because for a particular conductor value of R is fixed. Okay, now let me see, in this case, what is the value of I? Here, remember, potential difference is doubled. Let me see then, now the value of I. Let me get it by this simple formula. I equal to V by R. Let me see, the V is here how much? 20 volt. V is here 20 volt. And here we have R is 2 as usual. So we get 10 ampere. Mind it here. The potential difference get doubled. You see the current from 5, it also got doubled. Because we know 2 10 are 20 ampere or 10 ampere comes here. Now let me reduce it. Suppose V2 is reduced to, suppose here 5 volt. R will remain constant. Now what is I here? You see, I is V by, again R. Now V is here, we have 5 volt. R is here, we have 2 ampere. So we get 2.5 ampere. You see, from the original value 10 volt, it has reduced to 5 volt, becoming half. So originally it was 5 ampere, so it is reduced to 2.5, half. That means these two are directly dependent upon each other. If potential difference increases, current will increase, and if potential difference decreases, current will decrease. But remember, as many times potential difference increases, so many times current also will increase. And if the potential difference decreases, exponentially, in the same exponential manner, current also will get decreased. That's a very simple and easy way to understand this particular law. I don't think you have any problem in understanding this law now. We shall see now this resistance. Resistance R. Let me see it in this way. My dear students, to understand resistance is too easy. If somebody tries to pull you or push you, you will also try to resist, right? You won't allow somebody to push or pull you or drag you anywhere. You will definitely apply an opposite force to resist it. And this same force that is applied to resist is resistance. In literature term, the meaning resistance is this way. If somebody pushes me, I will resist. But in science, especially this part of the science, that's electrical part 1, the physics part, it is different. In electrical resistance is same resistance, but it is defined in a different way. You see, when current flows, we all know the electron flows through the conductor. But electron doesn't get a free permit to flow through the conductor. As soon as electron tries to flow through the conductor, the particles within the conductor, the free moving particle, the whatever particles are there within the conductor, they do not allow electron to flow that easily through it. They apply a force by collision. You know, when electron flows through that particular conductor, the particles within the conductor collide with the electron, thereby creating a resisting force to stop the flow of electron. Okay, this force that is applied by the particles of the conductor by collision to check or to resist the flow of electron through it is called resistance. So simple, just mind it that way. Resistance, very simply to make you understand, it is the force applied by the particles of the conductor to check CHECK the flow of electrons through it. Please mind, it is said it is resistance in this term is the force applied by the particles of the conductor to check the flow of electrons through it. In a very simple way, you should understand it in this way. And this is the being a class 10, and you should understand in the simplest possible term, because you have to develop the concept here. Okay, for your further uses, you should know, keep in mind that this electrical resistance is the resistance applied by the particles of the conductor by collision or some other method, whatever. Collision generally, okay, to resist or to check the flow of electron through that conductor. That's it. You will find here that a resistance is nothing but a resistive force, a force that is applied by a conductor's particles to stop the flow of electrical charges, especially electron, through it. Similar as if somebody tries to overpower us, we try to check, we try to imply a resistance. It should be taken so simply, okay? Do not take it so hard so that you will get suffocated. Very simple way, keep it in this way. This will be enough for your examiner, okay, to understand that the student knows the concept and the mark will be given. Don't worry about it. Now, you can see this resistance, no space, I'm just giving out here, has got SI unit called ohm. A symbol is given omega. This omega is the Greek letter, the last letter of Greek, I suppose, ohm. And this value is different for different material. Now, further, I'm trying to keep this vlog up to this much only. The further elaboration will be there in the next class. Till then, keep tuning in to this and do subscribe so that I can help all the students whosoever in need. Thank you very much. Till next class. Thank you. Bye.